Let's do some talk problems. We'll go through 7 questions in this video. For our first question, a 2.0 meter long uniform log is lying on the ground. The mass of the log is 42 kilograms. If you were to apply force at the very tip of the log, what is the minimum force you would need to apply to lift that end off the ground in newtons? For talk questions, I always like to draw a diagram. So I will draw a line to represent my log, then fill out the details. We know that the length of the log is 2.0 meters. Then the mass equals 42 kilograms. The log is uniform, which means that the center of mass of the log will be located at the midpoint of the length of the log. So we'll draw a force vector directed downwards at the middle of the log, and this will be the weight force of the log. Weight force is equal to mg, and remember that g is equal to 10 in PHSI191. So 42 times 10 is 420 newtons. Let's call this force 1. We can select one end of the log to be the fulcrum, and so let's draw a triangle to represent the fulcrum. This is the axis of rotation. The lifting force will be applied at the very end of the log. So on the opposite side, we will draw another force vector. Let's label it force 2. This will be directed upwards, and we want to find the magnitude of this force. So F2 equals question mark in newtons. We also need to draw in the distances from the fulcrum. Distance 1, or the distance from the fulcrum to force 1, will be 1.0 meters since it is half of the 2 meter plank. Distance 2, or the distance from the fulcrum to force 2, will be 2.0 meters. Torque is a moment of force that allows rotation of an object around an axis or fulcrum. The equation for torque is torque equals force times distance. The symbol that we use for torque is the Greek letter tau. You can see in the equation that the amount of torque produced is proportional to the distance from the fulcrum. The direction of torque can be either clockwise or counterclockwise. If an object is stationary or the rate of rotation is constant, then the clockwise torque and the counterclockwise torque must be equal. So we can write torque clockwise equals torque counterclockwise. And because torque equals Fd, we can write F1 d1 equals F2 d2. Using this equation in our problem, we'll fill in the numbers. F1 is 420 and d1 is 1. 420 times 1 is 420, so we can get rid of the 1. Force 2 is unknown and the variable we want to find. d2 is 2, so 420 equals 2 times F2. Divide both sides by 2 and F2 equals 210 newtons, which is our answer. Question 2. A wrench is 40 centimeters long and is secured onto a freely rotating bolt. You apply an upwards force at the tip of the wrench to keep it horizontal. The mass of the wrench is 800 grams and the center of mass is 15 centimeters from the bolt. What is the force you must apply to keep the wrench stationary in newtons? Let's draw this out. The wrench is represented by this line. The fulcrum is at the end, where it would attach to the bolt. The weight force is located at the center of mass of the wrench. Let's call this force 1, and it is directed downwards. Weight force is equal to mg. Remember that mass must be in kilograms. So 800 grams divided by 10 to the power of 3 is 0.8 kilograms. 0.8 times 10 equals 8 newtons. If the object is not uniform, then the center of mass may not be located at the midpoint of the object. In this case, the distance from the fulcrum, or d1, is 15 centimeters. Remember that we must convert this into meters. To do this, we can replace the center prefix with 10 to the power of negative 2, which is basically the same as dividing by 100. so d1 equals 0.15 meters. An upward force is applied at the other end. Let's call this force 2. Its distance is 40 centimeters from the fulcrum, and again, we need to convert this into meters. So 40 times 10 to the power of negative 2 is 0.4 meters. We can use the same equation where torque clockwise equals torque counterclockwise, since the wrench is not moving. This can be written as F1d1 equals F2d2. We can rearrange for F2 by sending d2 to the denominator on the other side. F2 equals F1d1 over d2. Let's substitute the numbers. 8 times 0.15 divided by 0.4. If we put this into the calculator, press the fraction button, then enter 8 times 0.15, then arrow down, then 0.4. This gives us an answer of 3 newtons. Question 3. You want to load plates onto an empty barbell that is 2.2 meters long with a mass of 20 kilograms. The barbell is symmetrical so that its center of mass is located in the middle. You need to apply 110 newtons of force upwards to lift one end. What is the distance from that end that you are applying the force in meters? Let's draw this out. The line represents the barbell. The triangle will represent the fulcrum. The weight force of the barbell will act downwards through the center of mass, located at the midpoint of the barbell. Let's call this force 1. Weight force is equal to mg, so 20 times 10 is equal to 200 newtons. d1, the distance from the fulcrum to force 1, is half of the length of the barbell, so d1 equals 1.1 meters. Let's draw force 2. Force 2 is an upwards force of 110 newtons. It is an unknown distance from the fulcrum, so d2 equals question mark in meters. Note that we have been asked to find the distance from the end that is being lifted, so we'll call this distance d3. d3 will be equal to the difference between the length of the barbell and d2. We must first find the value of d2. We'll use the torque equation F1d1 equals F2d2. Let's rearrange for d2 by sending F2 to the denominator on the other side. d2 equals F1d1 over F2. Substituting our numbers, 200 times 1.1 over 110. If we put that into the calculator, press the fraction button, then 200 times 1.1, arrow down, then enter 110. So d2 is equal to 2 meters. To find d3, we will go 2.2 minus 2, which gives us an answer of 0.2 meters. Question 4. A poorly designed seesaw with a length of 4.4 meters is uniform and has its fulcrum located 2.0 meters from the left end. It requires an upwards force of 280 newtons applied to the right end in order to keep the seesaw horizontal and stationary. What is the mass of the seesaw in kilograms? This line represents the seesaw. The fulcrum is located 2.0 meters from the left end. There is a force of 280 newtons directed upwards at the right end of the seesaw. Let's call this force 1. The distance from the fulcrum will be 4.4 meters minus 2.0. So d1 equals 2.4 meters. We have been told that the seesaw is uniform, so the center of mass is located at the midway point of the seesaw. This will be 2.2 meters from the left end. Remember that we always want our distances from the fulcrum when doing torque problems. So d2 will be 0.2 meters. The weight force of the seesaw will act through this point, and we need to find the magnitude of this force. So F2 equals question mark in newtons. Let's use the torque equation and rearrange it for F2. F2 equals F1d1 over d2. If we put in the numbers, then 280 times 2.4 over 0.2. Let's put this into the calculator, and we get an answer of 3,360 newtons. Now we want to find the mass, so we need to rearrange the weight force equation for mass. Mass is equal to weight force divided by g, which is 3,360 divided by 10. That gives us 336 kilograms. We can round it to two significant figures, and the answer is 340 kilograms. Question 5. A rope is attached to a log that is lying on flat ground. It is attached 1.0 meters from one end. The log has a length of 10 meters, a mass of 60 kilograms, and is uniform. What is the tension force in the rope when the end of the log closest to the rope starts to lift off the ground in newtons? This line represents the log. We know that the log's length is 10 meters. Let's draw the upwards force applied by the rope on the log 1 meter from the end. Let's call this F2. We need to find the magnitude of this force. The axis of rotation will be around the other end of the log, so the fulcrum can be drawn at the other end. The distance from the fulcrum is 10 minus 1, so d2 equals 9 meters. Next, the weight force of the log will be acting through the halfway point of the log, since the log is uniform. So F1 will be directed downwards and is equal to the weight force. Weight force equals mg, and the mass of the log is 60 kilograms. So F1 equals 600 newtons. The distance from the fulcrum to F1 will be 5 meters. We can use the torque equation, so F1 d1 is equal to F2 d2. We need to rearrange for F2, so F2 equals F1 d1 over d2. That will give us 600 times 5 over 9, which gives us 333.33. The answer can be rounded to two significant figures, and so our answer is 330 newtons. Question 6. A robot arm has the forearm at horizontal. The pulley attaches to the forearm 2 centimeters from the elbow joint and exerts a vertical force upwards. The mass of the forearm is 1 kilogram, while the mass of the hand is 500 grams. The center of mass is 20 centimeters from the elbow joint for the forearm, while it is 30 centimeters for the hand. What is the upwards force that must be exerted by the pulley in order to keep the forearm and hand stationary in newtons? In this problem, we have 3 forces involved. 2 of them are in the counterclockwise direction, and 1 is in the clockwise direction. Let's call the weight force of the hand F1 and the weight force of the forearm F2. The force exerted by the pulley can be F3. In this problem, we can write F1 d1 plus F2 d2 equals F3 d3. We need to find F3, so we can just send d3 to the denominator on the other side by dividing both sides by d3. F3 equals F1 d1 plus F2 d2 over d3. Before we substitute the numbers, we should convert the values into the correct units. d1 is 30 centimeters. To convert into meters, we replace the centi prefix with 10 to the power of negative 2. So d1 equals 0.3 meters. d2 is 20 centimeters, so it becomes 0.2 meters. d3 is 2 centimeters, so it becomes 0.02 meters. The mass of the hand is 500 grams, and we need to convert into kilograms. To add the kilo prefix, we divide by 10 to the power of 3, which gives us 0.5 kilograms. F1 equals weight force, so 0.5 times 10 is equal to 5 newtons. The mass of the forearm is 1 kilogram, and F2 equals weight force, so 1 times 10 is equal to 10 newtons. Now that we have all of the values in the correct units, let's substitute them into the equation. 5 times 0.3 plus 10 times 0.2 over 0.02. That gives us an answer of 175 newtons. Question 7. A 3.0 kilogram cat is sitting on a plank 1.0 meters from one end. The plank is uniform, 3.0 meters long, and 10 kilograms in mass. You lift one end of the plank that is furthest from the cat. How much upwards force do you need to apply in newtons? So let's draw this out. Here's the plank. The length of the plank is 3.0 meters. Let's place the fulcrum on the left end, and the cat is sitting 1 meter from the end. It will exert a weight force of 3 times 10, which is 30 newtons. The plank is uniform. The center of mass will be located at the halfway point of the plank, and this is where the weight force of 10 kilograms will act. The weight force is equal to 10 times 10, so 100 newtons. The distance from the fulcrum to force 2 will be 1.5 meters. You apply a force at the end of the plank that is furthest from the cat, so we'll draw the force vector on the right side of the plank. Let's call this F3. D3 will be 3 meters. We can use the torque equation F1d1 plus F2d2 equals F3d3. We want to find F3, so we can rearrange for F3 by dividing both sides by d3. If we put the numbers in, then it becomes 30 times 1 plus 100 times 1.5 over 3. We get an answer of 60. F3 is equal to 60 newtons. That's all of the essential torque questions. Try to solve them on your own, and if you get stuck, you can come back to my video. In the next video, we'll go over simple harmonic motion. See you there.